All right, welcome back. Today we're talking about day 2 of section 10.4 of the hyperbolas, center point at HK. So your homework with this, you guys already did the front page last week. So with this section, you're just doing page 2 now of worksheet 10.4. There's only that one worksheet. So we'll go ahead and start with the basic rundown here of the notes. So like last week, remember if x squared was first, you had a hyperbola that opened left and right. And if y squared's first, you have one that opens up and down. That has not changed. The only thing that's changed now, instead of having x squared, y squared here, because it was centered at 0, 0, now you have h and k. So again, we're going to move this left or right or up and down. Our focal axis now will go through, if x squared is first, will be the k value. If y squared is first, it's our h value. And you can see we add c accordingly for our foci and a for our vertices. The transverse axis is still a. The conjugate axis is still b. That's what makes the little box. So when you have the box here between the vertices, that's what a and b are, so that we can get our asymptotes. Pythagorean relationship is still a squared plus b squared equals c squared. So if you're looking for c, you're going to take the square root. That has not changed. And our asymptotes, you can see, again, b over a here and a over b. The only difference, again, is h and k in the equation. So always refer back to this page if you get stuck with where you're putting your numbers. But as long as you have a, b, and c, you can find the foci, vertices, and asymptotes. As always, it's a little easier with numbers, so we'll go ahead and take a look at that. So it says find standard form for hyperbola whose transverse axis has endpoints at -4, 3, and 8, 3. So that's really our vertices is what they've just given us there. And the conjugate axis has a length of 10. So if the conjugate axis has a length of 10, that's equal to 2b, and we know that b is 5. We know the distance between our two vertices is 12, so a is half of that. A is 6. And our center point has to be halfway between our vertices, so the center point, if you do the midpoint of these two, going way back to the start of the chapter, the midpoint's at 2, 3. So now we have h and k. X is first, since this opens left and right, so x minus 2 squared over a squared, so 6 squared is 36. Y minus 3 squared over b squared, so 25 equal to 1. Remember, hyperbola, always minus here. So an ellipse is a positive. Hyperbola, you have a negative there, always equal to 1. All right, here they gave us the equation. Again, x squared is first, so we know it's a very rough sketch. We know it opens left and right. We can get a and b just by taking the square roots right here. And our center point is at -2, 5. So that's the first thing we can find. We got -2, 5. We can find c, since we have a and b, so 9 plus 49 is 58. The square root of that is 7.62. So for our foci, we will add and subtract c from our center point, and that'll give the foci on either side. So I took 7.62 minus 2 and 7.62 plus the -2. And so that's how we got these values here. And our vertices, again, we know our a value, so you're going to take a and subtract that from the x corner of the center point and add that. And that's how we got the two vertices. All right. Eccentricity, that's basically, when you find that, it's still c over a, and that's a measure of how stretched out or elongated the hyperbola is. In other words, whether it's real skinny or whether it's real wide. So that's what the measure of the eccentricity is. We really don't do a lot with that with hyperbolas. So it says prove the graph or prove the equation of the hyperbola, find the vertices, foci, eccentricity, so forth. All right. So you can see that this is not in standard form. We're going to have to do that. So right now we kind of got a mishmash of all our terms. So we're going to group our x terms and our y terms, and then we're going to end up moving to constant. We're going to have to complete the squares, what's going on. Now you may be wondering, why did I put the y squared term first? The reason I did that, if you notice, this one's negative. So whichever one is negative, put that one second. So the y squared was positive, so you see I put that first here. Put the x term second since this was negative. Move the 281 over. At this point now, I'm going to divide out the lead coefficient here, divide out to 25, and I get y squared minus 2y. I'll come back to this in a second. Divide the negative 9 out of the 2x terms, and so now I can complete the square. So half of negative 2 is negative 1. Negative 1 squared is 1. So why did I add 25 over here? 25 times 1. Half of 6 is 3. 3 squared is 9. Negative 9 times 9 is negative 81. So if you're wondering why I added 25 and negative 81 here, why this says plus 1 and plus 9, because we have to multiply. At this point, we're in really good shape to complete the square. So this is y minus 1 squared. This is going to be x plus 3 squared. These worked out well for us at 225. My last step here, I'm going to divide, because this has to equal 1. I'm going to divide all of these terms by 225. And when I do that, my a value is 9. My b value is going to be 5. And we can find c. We'll do that in a minute. We know this one opens up and down because y squared's first. Center point at negative 3, 1. Be careful because the h value always goes with the x. So negative 3, 1 is our center point. Opens up or down. So our vertices are going to be a units up and a units down. So when we do that, if we add 3, let me get rid of this shade here real quick. Alright, so a units up and a units down. So I'm going to add 3 to 1, and I'm going to subtract 3 from 1. So there's my vertices. And for my foci, I'm going to add the c value and subtract the c value from here. So add these two together, I get 34. Square root of 34 is 5.83. So I am going to add 5.83 to 1 and subtract 5.83 from 1 to get the foci. Eccentricity is just c over a. All they want is the number there. You don't have to make any determinations of what that means or what that tells you. But you just found the calculation. That's all you got to do there. I did not have to graph this one. I mean, if you did, you definitely could. If you had a graph provided, but they just wanted the center, vertices, and foci. All right, one last problem for today, and that is a word problem. So we have a semi-elliptical garage structure. So basically, if we were going to complete this whole thing, we'd have an ellipse. We just have half of it. You may see this as you drive around, like a greenhouse-looking shape, or some people have miniature ones that they can park cars or boats or whatever under. So this one's a garage structure, has a width of 20 feet and a height in the middle of 8. And so we want to know if a pickup truck that's 7 feet tall and 6.5 feet wide would fit in the middle of this garage. Clearly I can't drive it right up to the edge here because I would hit the side. So we're going to have to park this truck in the middle if it'll fit. If it's 20 feet across, then we know that a half of that is 10. We already know that b is 8 because it said semi, so half of an ellipse, so we know b is 8. I purposely put the center point at 0, 0. You can make whatever numbers you want, but I just put it at 0, 0 to keep it simple. So we know that x squared is over a squared, so 10 squared is 100. Y squared over b squared. So here's our equation. Now, where did this 3.25 come from? Well, if I take this pickup truck and I park it smack dab in the middle, I would have 3.25 feet of the truck on each side because of the width. So we know the truck has a height of 7 right about there, but we want 3.25 feet on either side to center it in this garage. So that's where the 3.25 came from, and now I can plug that in here and solve for y. And so when I do that, let me just extend this here. So I put 3.25 in for x, and I'm going to solve this for y squared. Basically, I'm going to get a decimal here, subtract that from 1, then multiply by 64. That gives me this number. Then I take the square root. I get 7.57 feet. So what that tells me is when I put the truck in here, and I have 3.25 feet on either side, the height at that point straight up is 7.57. The height of our truck is 7 feet, so the truck's going to fit. It's going to be right in here. Going to have about a half foot of room at the top to get that truck in there. So yes, the truck does fit. So thank goodness we didn't scratch it a little too pretty to be running into the side. So that's your notes for today. If you got any questions, as always, shoot me an email or request for Google Hangouts, and we'll take care of that. All right, thanks a lot.